Thank you for coming to the brown bag lunch joining us today. Today we're very pleased to have Dr. Nobuko Shibayama to join us, and she is a specialist in organic dyes. Dr. Nobuko Shibayama, she right now is the associate researcher at the Scientific Research Department at the Metropolitan Museum of Art. She received her PhD in Applied Science from Kyoto Institute of Technology, and she also has a diploma in textile conservation from Kyoto Institute of Art in London. She has been working at the Met for 15 years, and prior to coming to the Metropolitan Museum of Art, she also worked at the National Gallery of Art in Washington, D.C. During her past 15 years at the Metropolitan Museum of Art, she participated in numerous projects, and she also published a lot of articles related to those projects, such as analysis of natural dyes and metal threads using 16th to 18th century Persian and Indian velvets to investigate the systems to differentiate velvets of two cultures, and which was published in Heritage Science. And she also has articles like identifying natural dyes to understand a tapestry's origin, and tracing cochineal through the collection of Metropolitan Museum of Art, and so on. So feel free to ask her any questions about organic dyes. She has many experiences, and her case study ranged widely from ancient Chinese textiles to Persian to American and in Latin America, many different case studies. And today she's going to share some case studies from her projects at the Metropolitan Museum of Art. Let's welcome Dr. Shibayama.
Thank you very much. Thank you very much for your kind introduction and for giving me an opportunity to give a talk here. So today I'd like to talk about case studies of analysis of organic colorant used in art object. As Stephanie just mentioned, I worked at the Department of Scientific Research of the Metropolitan Museum of Art, and these case studies were carried out there. So the content of this talk is, the first, I want to mention what I do and why I do it at the science department. And then I talk about three case studies of dye analysis of 16th century Flemish tapestry, 16th, 18th century Safavid and Mughal velvet, and 16th, 17th century colonial Latin America textile. So the science department at the Metropolitan Museum of Art was founded in 2004 to provide scientific capability to the museum, and the museum hired Marco Leona as the head of the department. Currently, 8 scientists work at the various subjects and materials, and 4 more scientists will be hired next year to meet the volume of demand request, which we receive from the entire museum. And we receive requests from various tutorial departments, such as the medieval art department or Islamic art department, and also from the conservation department, textile object, painting, paper, or photo conservation department, and we work on the request. The type of request are the analysis of materials used in art object, test or investigation of conservation or display materials and method, investigation of environment in gallery or storage or pest control, or any issue which science can help to solve the problem. So what I mainly do is in the department is to analyze organic colorant used in art object. So the reason which I do is to provide information to the curators, conservators, and the public, helping them understand both the context and the physical makeup of the object. The kind of information which I provide are provenance of object, probable colors from studying fading colors, recommendation for display and storage of the object, because some dyes are very light sensitive, and also information about history of technology of organic colorant. So more analysis I do, I can provide better information because I can build a bigger database. So the first case history is a project of a tapestry for this show. Grand design Peter Cook van Elst and Renaissance tapestry at the Metropolitan Museum of Art last October, which was curated by Lizzie Cleland, a curator of the European sculpture decorative art. Peter Cook van Elst is a 16th century Netherlandish artist, and he also designed a tapestry cartoon. This tapestry belongs to Met collection and is attributed to have woven based on his cartoon. According to Lizzie, this tapestry is always put in a state as inferior quality and possibly even suggested as a 19th century production. So in order to clarify the attribution, detailed technical examination and analysis were carried out. So we approach to solve the question as shown in this slide. Lizzie plans the project and studies the historic background of the tapestry. Giulia Ciostrini, a textile conservator at the museum, studies the weave structure, fiber, and restoration and conservation history. And in science department, Federico Caro analyzed metal thread and mordant, and I analyzed dyes used on the tapestry. The main analytical method used for this study was liquid chromatography with a photodiode array detector. So in this method, a small thread sample was taken from the tapestry and dyes were extracted with a reagent assisted with heat. And then extract is analyzed by the machine shown in the previous slide. This is the way which HPLC works. An extract from the sample yarn is introduced through the injector, and the color component present in the extract are separated by interaction of the solid phase in the column and mobile phase, the liquid mobile phase. The separated color compound passed to the detector, in this case a photodiode array detector. In the detector, the UV visible spectra of the component are measured and recorded. This is an example of the test result. This sample was an extract from a yarn dyed with mother, modern natural dye plant. With this detector, UV visible spectra of the component in the extract are collected three-dimensionally, as shown in this diagram. And the x-axis is the time, and the y-axis is wavelengths, and the z-axis is an intensity of absorbance. The diagram, this diagram shows the data at one wavelength, in this case 450 nanometer. Usually natural dyes consist of many color components, some are major color component. And these peaks are the color component from the dye plant. And these two peaks are obviously the major color component. So each peak provides the UV visible spectrum of the component in the peak. So when the same chromatogram and the UV visible spectra were obtained from a sample of historic tapestry, one can conclude that the sample is dyed with the dye plant mother. So back to the tapestry, Giulia, the textile conservator, found from her examination that the main panel and the top and bottom border look different, and that those borders seems to be attached later. So only the main panel and the border at the right and left side are the original. And these dyes were identified from the main panel and the left and right side borders. Mother, Weld, Ward, Dyed Bloom, Ochil, soluble red wood dye, and cochineal. All of them are natural dyes. I quickly show what those dyes are. Madder is a red dye used in Europe since Greek and Roman times. This red root is used as a dye. It is known to be relatively light fast. In the medieval period, it was already cultivated and readily available. Because the plant can be cultivated in many places, and also because material dyed with it is light fast, the dye has been popular through centuries. Weld is a yellow flavonoid dye, a major yellow dye used in Europe since ancient times. I have analyzed quite a few yellow yarns from European textile, and a majority of them were dyed with weld. So wood was used for the blue and green yarn. Wood is a blue dye. The most of blues in historic textile were dyed with wood or indigo from species of Indigofera. The main colorant of both of them are the same compound called indigotin. Wood was the only blue dye available in Europe until the 16th century, and later replaced by indigo from Asia during the 17th century through the seaway to the Far East. So ochre is a dye extract from lichen, used fairly often in European tapestry and textiles. It shows a very poor light fast, often found brown in the front of the textile, but purple remains in the back. I read that since ochre found a lot on coastal cliff, employees who collected ochre sometimes died by failing from the cliff. So these were known as dyes since before Christ, but seems to have been prohibited from use in later time, probably because of the poor light fastness. Another flavonoid yellow dye used was the dyer's broom. I read that this dye was particularly popular in England. Another purple or red used was soluble red wood dye. This dye also showed poor light fastness. This soluble red wood dye could be sappanwood from Asia or Brazil wood from America. The main colorant of those dyes is the same, called Brazilian. This pink and some flowers on the side border were dyed with a mixture of cochineal and madder. Cochineal dye is extracted from an insect, a parasite of cactus, and originally from Central and South America. The dye is fairly light fast. So the summary of the dye analysis is that in the major part of the tapestry, traditional dyes to Europe were used. In a small part, cochineal from America was used. So cochineal came to Europe in about 1520, soon after Columbus found America. Also, looking at the mordant sometimes is a good marker to know the date. Mordant is usually a metal ion which binds a dye molecule to fibers. A combination of tin and cochineal is reported to be used after the middle of the 17th century to obtain bright scarlet. This pink dye with a combination of cochineal and madder is much brighter pink in the back. And I wondered if tin may be used for the mordant. And Federico, the scientist, looked at the mordant by scanning electron microscope with energy dispersive spectroscopy, but aluminium was detected, indicating that alum was used as mordant. Alum was used as mordant since ancient times. So, of course, this doesn't mean that the pink yarns was not dyed after the mid-17th century, but at least the result didn't push the date forward. As for the restoration border, a mixture of natural dyes from America and early synthetic dyes were used. One of the early yellow synthetic dye found from the border appeared to be available after the end of 19th century. And the commercial use of natural dyes were until around 1920. So the border was possibly woven around the end of 19th century. So the main panel has to be created before that. So the conclusion of dye analysis is major dyes used were typical European dyes, and there are minor use of cochineal from America and no use of tin mordant. And the restoration border was probably woven around the end of 19th century, and the main panel must have been woven before that. So there was no definite evidence, but the result supported the proposed date, the middle of 16th century, when a new dye from America just started to appear in Europe rather than conflict with the date. So the conclusion of this project was the examination of the weave structure by Julier, the textile conservator, showed that the quality is high and the quality of weaving can be placed in 16th century Flemish tapestry production. And Federico analyzed the metal wrapping of metal thread, and he found that metal wire was cut in strip, which technique was used in Europe up to 16th century. And dye analysis showed no conflict with the date. So together with the curator's research on the tapestry history, the tapestry is consistent with the production carried out in about mid-16th century. So in case of tapestry, how weavers translate the cartoon to make the tapestries the big factor of the final production. It is not like the painting. So that could be one of the reasons that it has been confusion about the date of the tapestry. So the second case history is about the analysis of dyes used on 16th, 18th velvet produced in Safavid Empire and Mughal Empire. This project was conceived by former Mellon Fellow Elisa Gagliardi Magiri and Mark Lipsky, one of the scientists of the science department. So when I looked at those Safavid velvet, and some of the velvet had this strange shape, and I asked Elisa why it had this shape, and she said that it was used to decorate a tent. So I imagined a tent like this, and then it kind of didn't make sense. So I kind of Googled a Safavid tent or tent in Islamic culture. And I came across this image, and this is not a Safavid tent, it's an Ottoman tent, which is now displayed in Dresden. But I realized that those fragments of Safavid velvet must have been used in such amazing tent like this. So I'd like to briefly mention the background of this project. Safavid Empire was in an area where currently Iran is located and ruled the area in 16th, 18th, and Mughal Emperor was in India in 16th, 19th century. Textiles like velvet have a very complex structure. They were woven using a complex loom and needed a skilled craftsman. The weaving and the dyeing technique used on Safavid velvet are known to be exquisite. And it is known that the Indian Mughal court had a strong relationship with the Persian Safavid court. The Persian artisan and craftsmen were recruited by a Mughal emperor for the service in Mughal court, and the result of that, Mughal art, including textile, absorbed the very refined taste of Safavid art and craft. So they are very similar and not easily distinguishable, and it has been a problem to categorize them properly. So the objective of this project was to investigate whether velvet from the two cultures could be differentiated by their dyes and the type of metal used, along with their particular weaving techniques, and to examine whether such information could support the historical and iconographical approach which has been traditionally used. So the way to approach of this project was Elisa studied the historic background and examined the weave structure and fibers, and Mark Lipsy investigates the metal thread using SEM-EDS, and I analyzed dyes using HPLC with a diode array detector. So in this talk, the dye analysis is focused. So the summary of the dye analysis result was, although the number of the sample was limited, and particularly the sample for Mughal velvet, there were type of dye which appear to characterize one or the other of those velvet production, although there were some exceptions. And there were also type of dyes which have been used in both production. So red dye used for the Safavid was mainly cochineal and lac for the Mughal velvet, though there were exceptions. Both dyes are produced from insect. The red from the Mughal velvet seems to have used their local dye, lac, and the cochineal used for Safavid velvet could be from South and Central America, or could be from Armenia in Middle East. Colorant of cochineal from Armenia and cochineal from Central and South America are very similar, and it is difficult to distinguish. So the oldest Safavid velvet studied here are dated around 1540, and the cochineal in America was reported to be brought to Persia through Venice before the end of 16th century. So many cochineal found in those Safavid velvet are probably cochineal from America. So a main yellow dye used for Safavid velvet was mainly yellow larkspur, Delphinium zari. The flower was used to dye the fabric or yarns. It is native to Afghanistan, Iran, and northern India, so it looks like that they used their local dye. So, and the main yellow dye used for Mughal velvet was turmeric. As you know, turmeric is a spice for the curry. It is native, turmeric is a native of South India, so Mughal velvet also used their local dye. So dyes commonly found in the both velvet are safflower for pink or salmon, tanning dyes such as oak gall or mirobalan for the black or brown, and indigo dye for blue or green. So this is a table of summary of dyes used in both velvet. So mainly pile were analyzed here, and the materials were all silk. So I want to point out the green yarns. The both appeared to have used the combination of yellow larkspur and indigo dye, although some Mughal velvet used a combination of turmeric and indigo. And yellow larkspur was more characteristic yellow yarns of Safavid velvet. So in general, red and yellow dyes seem to show that they used their own dyes to weave velvet, but green yarns looks like that the materials are brought from Persia to India to weave velvet. So as for the metal thread, difference was also indicated. All the metal was fairly high purity silver, and many of them are gilded. But the copper content in the silver in the Persian velvet was slightly higher than that in Mughal velvet. But Mark said that the number of the samples analyzed were not large, and the difference is very small, so further study is necessary. So in conclusion, so the question was if it's possible to differentiate velvet from the dyes used. So the answer is that although by looking at one specific dye, the two production couldn't be accurately differentiated. Examination of the range of dyes used in the velvet has provided some indication of their probable origin. So in addition to knowledge gained from the historical and iconographic studies, the information on dyes, weaving technique, and metal thread also suggest idea about the origin and the basic makeup of the production. I wanted to mention the fading aspect of those velvet. When the light green sample from the velvet were analyzed around here, indigo and also unexpectedly calsamine, which is the main colorant of safflower, were detected. So safflower is known to be very light sensitive. The assumption is that safflower faded from pink to yellow, and with indigo blue, it looks now light green. And there was a purple from the Safavid velvet, in which color looks preserved very well. And the purple pile was dyed. This purple dyes were dyed with a mixture of safflower, indigo dye, and yellow larkspur. So this light green may have been purple like this velvet, in this velvet. So the last case history is about dye and dye analysis of the 16th, 17th colonial Latin America textile. This project was planned by the Elena Phipps, and who was a senior textile conservator at the Met, and worked with Lucy Commoner, the Cooper Hewitt Museum, Mark Lipsky, the scientist, and Matthew, he was a fellow at the National Gallery of Art in DC. Elena Phipps and Johanna Hex of the Metropolitan Museum of Art organized a show in the fall of 2004 at the Met entitled Colonial Andes, Tapestry and Silver Work, 1530 to 1820. Elena considered to include this textile to the show, which belongs to the Cooper Hewitt National Design Museum, because it was catalogued as Peruvian textile. But questioned the Andean provenance of the textile because of the unusual physical characteristic for Andean textiles. So she thought that it's possibly Mexican origin. So Elena and Lucy at the Cooper Hewitt started investigating this tapestry. This tapestry was accessioned to Cooper Hewitt collection in 1902 and has been catalogued as Peruvian. It is a tapestry woven band and possibly used church for altar. So the purpose of this investigation is to clarify the origin of the tapestry, which has been attributed to Peruvian. The aspect of the investigation included analysis of the fibers, the weave structure, and carbon-14 dating, and also dyes used on tapestry, which I'm going to talk about it today. Before talking about dye analysis, I quickly go through the investigation by Elena and Lucy about the fibers and the historic background. Two types of yarn were used on the tapestry: cotton fiber spun with feather. You see the feather in this magnified image, and rabbit hair. Rabbit hair are more characteristic to Mexican textile. Andean textiles usually use llama or alpaca fibers. These microscopic images show the characteristic of rabbit hair. They also worked with scientists at the National Museum of Natural History of the Smithsonian Institute to identify the fibers. They also investigated the history related to a technique and materials of textile in ancient Mexico. Also in Florentine Codex, which is one of the major sources of Aztec life before the Spanish conquest, their feather workers are well documented. So all this evidence propose the Mexican origin of the tapestry rather than Andean origin. So for the detail of those investigation, please refer this paper presented at the Symposium of the Textile Society of America in 2007 by Elena and Lucy. So the next step was that if the dye used on tapestry tell us about the origin. So this is a detailed photo of the tapestry, and the dye used on the 6-colored weft were analyzed: red, yellow, dark green, green, light green, and gray. The gray appeared to be naturally pigmented rabbit fibers. So I'd like to explain the analysis of dyes of the yellow and light green yarns because they are unusual dyes. So literature search showed that those two yellow dyes, Zakatoraskari and Zachipari, were mentioned as representative dyes used in ancient Mexico. Zakatoraskari is a yellow dye from the plant Cuscuta species, such as Cuscuta tinctoria or Cuscuta americana. It is a parasitic plant, and the vein wraps around the host plant. The common English name is Doda. Fortunately, Elena found reference yarns dyed with modern Cuscuta plant, Zakatoraskari, and Cosmos Zachipari. So I analyzed them by HPLC. I also analyzed the reference samples dyed with dye plant, which are reported to be used in Peru. So among them, Cuscuta plant showed a good match with the yellow yarns from the tapestry, as shown in these chromatograms. So UV spectra of the three main peaks in the reference sample of Cuscuta plant and the yellow yarn from the tapestry also matched well. And these are UV spectra of the three peaks from the yellow yarn from the tapestry and the reference sample of the Cuscuta plant. So these yellow yarns appeared to be dyed with the dye plant of Cuscuta species, Zakatoraskari. As our best knowledge, although Cuscuta plant is reported to be used as a dye in Mexico in literature, this is the first time when the Cuscuta dye was found from a historic textile. Also, these spectra show the characteristic of flavonoid compound. So flavonoids are responsible for the yellow of the yarn. I want to explain the flavonoid quickly. Flavonoids are plant secondary metabolite, and this kind of structure, chemical structure, it is known for their antioxidant human health benefit, and there are many kinds of flavonoid. And they are the colorant of the major group of natural yellow mordant dye. For example, luteolin is in the world, or lutein is in pagoda tree, which is a common yellow dye in China or Japan. So the next result is a light green yarn from the tapestry. The chromatogram at 350 nanometers showed two main peaks, and these are the UV visible spectra of the peaks. These spectra show that they seem to be a flavonoid, which I just mentioned, but they didn't match any reference dye which we have. So they are unknown flavonoid, and this was a totally unknown dye. So we used an advanced analytical technique to identify the dye, which is called liquid chromatography mass spectrometry, mass spectrometer. In this technique, the mass spectrometer was added as an additional detector. The additional detector provides information about the molecular weight of the compound and the elemental formula. For example, a molecular weight of the luteolin is, which is a main flavonoid in the world, is 286, and this is elemental formula. Also, the detector can break the molecular ion, and the broken ions, called fragment ions, are specific to the original molecular ion. So you can elucidate the chemical structure of the original molecule from the fragment ion. And by analyzing light green yarn sampled by the technique, it was possible to identify or characterize the compound. And these are the compound, the flavonoid in the light green yarn sample. And we searched the database of flavonoid and found that those flavonoids are found from this plant, Garipia trifoliata, in French Guiana. The common name seems to be Angostura. So we asked the New York Botanical Garden if they have a plant, and they had an unknown species of the Garipia. So this is the inside of the stem and had a green bark, and when they are extracted with methanol, the solution became a very beautiful green. But when it was analyzed, it didn't match to the light green yarn exactly, and probably this is not the species which we look for. But similar flavonoid was detected in the plant from New York Botanical Garden, so it's possible that light green yarns, the tapestry was dyed with Garipia trifoliata. So as far as I know, no one has reported about this dye used in historic textiles. So this is a summary of dye analysis. The red weft is dyed with cochineal, and the dark green weft was dyed with lead soluble dye such as Brazil root. And cochineal and Brazil root are documented to be available in both colonial Mexico and in Andes. The yellow and green yarns appeared to have used Cuscuta dye plant. The light green yarns may be dyed with Angostura, Garipia trifoliata, which originated from the southeast part of the South America. So the conclusion of this investigation is so far, at the beginning of the talk, study on the fibers and the historic background proposed that the textile is Mexican origin. And cochineal and Brazil root do not suggest the origin. But the Cuscuta plant, which was used on the yellow yarn, supports the idea that the tapestry is a Mexican origin rather than Andean origin. And further investigation about the light green yarn will be done to see if it supports the Mexican origin or not. So thank you very much. That's for your attention.
Thank you, Nobuko, for really fascinating case studies. We show us different really spectrums of how dyes are used in different cultures. And we found what kind of dyes used originally from different parts of the world. You see the global history of material culture around the world. Now we're open to questions and comments. Anyone?
Okay. Thank you very much for this wonderful talk. I have one question. You should be the lead. Now I can see it. Okay. Let's say in the case of the cochineal, yes, that you discussed, is there any possibility that what you detect to be cochineal was added after time, was not part of the original dye, was something that was a result of, let's say, it being, the textile being, after it was made, in the vicinity of, let's say, a box full of these insects? To what extent actually the specific origin of the cochineal is absolutely certain that relates to the moment of the dyeing, and it's not something that was added after by means of nature or time?
Yeah, I mean, it's always possible, like it could be restoration yarn.
Yeah.
And Elena said often Indian blanket, they unravel the original yarn and they weave again.
Mm-hmm.
So it's always possible.
So is there a way of cross analysis in which we can,
if it's
like an external evidence outside of the object that might help us?
yeah, it's kind of always work with conservator and curators,
Mm-hmm.
and then ask conservators I ask them if it's original or restoration yarns,
Mm-hmm.
or it's something you're looking at the object, entire object, and then it's something strange or really a part of the object, or real. If you look at the weaving, often you can tell it's added or not, or but always just what we do is detect the main colorant, and then talk about it's died or not. So if it's someone added later, it's difficult to tell. But there are sometimes evidence someone added later or looking at just the entire object, you can tell.
Thank you. Thank you very much.
What would you project for further study on the Angostura? What would come next?
I want to find this plant and then analyze the Galliperia trifoliata. New York Botanical Garden just had an unknown species of Galliperia genus. So yeah, I want to.
You have to go to Guyana. Would you have to go to Guyana and look?
Yeah, or I've been writing to many people if they have the plant or not. Yeah, but I wish I could go to go to the forest and collect cut.
How big is the database now of the South American?
It's how big is the number? It's not large. Just some couple of book has a sample, so maybe 30, 40. But it's not a studied area like South America or Asia. So we want to focus more kind of area studying the area.
Just about the samples that you take for dye analysis, how big are they, and is it harder with are different fibers more difficult to take samples of than others? Or?
Yeah. Yes. Yeah. I take like a 5 millimeter for like red, and then like 1 centimeter yellow or safflower type. But could be 1 millimeter is good. There's some red, but it's faded yellow. Like I analyzed 5 millimeter, I couldn't see anything. But it's hard to predict how much degraded. The yellow difficult, safflower difficult, but blue, indigo, like red is easier, smaller, and yeah. Like recently, I analyzed like less than 1 millimeter, and then I thought I can't detect, but actually, I see it. But often, conservator says, "Oh, this is our last chance. We're gonna do a pressure mounting." So I try to take a little bigger, so that. Yeah, if you go to display or gallery, I can't do anymore, take anymore. So, but the Marco, the head of the department, working on a surface enhanced Raman spectroscopy, which, like he said, one fiber can be analyze. You can analyze the dyes. So we were working on a non-destructive way or much micro, using a micro sample to identify. It's just a. Idea is that we should use non-destructive way. That's the idea. So I'm working on a much more micro. But it's difficult to sometimes 1 or 2 fiber just to, while analyze, while handling go somewhere. So it's not, it needs to be easy to physically manipulate.
I was curious about the chemical stability of these dyes you're talking about, because you mentioned in multiple instances you're using modern reference spectra to compare against historically expected dyes. And yeah, can you say something about that? Whether you would expect any sort of chemical change over time?
Yeah. Yes. 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 There are some, like Brazil has a very good marker, degraded compound. So also that we are going to look for some degraded compound, and then from the degraded compound to identify the original. But it's not often. I don't kind of when it's degraded, just I can't see it yet. I mean, you need to do a study. maybe I'm seeing it, but I'm not noticing that's the degradation product of the dye. It's an interesting and important subject for us to look into.
Actually, I have another question related to this discussion. Is that I'm interested in the mordant, and I'm just wondering, does it matter to use what kind of mordants? And does the mordant in some way might have changed the characteristics of the dyes?
Yeah, it's like more like is some of them may accelerate degradation.
So do you have a database for mordants?
Not so much, but no, not so much. We haven't had a time to look into more than yet. Yeah, but like iron degrade fiber, that's well known. Iron and tannin combination with the black degrade fiber. Quicker, that's kind of well known sort of phenomenon.
The Met Costume Institute owns amazing 18th century English and continental dresses and crackers. And periodically you see in the labeling they say English or, cotton or silk painted. And one looks at the textile and thinks, is that painted with dyes or watercolor, or one can't imagine, on canvas. Have you ever been asked, have you ever been given a piece from the Costume Institute and been asked, what is the, in quotes, paint that has been used on this painted silk or painted cotton dress? And are they pure dyes applied by an artist, or are they watercolor, or are they pigment in an oil suspension? What have you experienced, if anything?
I haven't analyzed, but could be like inorganic pigment or organic-based pigment with like animal glue or something.
So it really is more of a paint that we would consider paint, rather than applied fabric dyes in a pattern with a brush.
If you're talking about the two painted dresses that were recently in China through the looking glass, they have been analyzed, and it's paint. It's an inorganic paint, not an organic color.
Do you know what binder is?
Not off the top of my head. There are actually two different binders. One being done, a European binder, and one being done in China. But there was a publication that was put out maybe 15, 20 years ago. If you want to talk afterwards, I can give you my information and you can see about getting that publication.
Thanks.
Yep, I work there.
Cool.
Thank you.